Good morning.
Good morning.
How's everyone doing?
It's Friday for us.
Yes, I agree. All right, I hope we have a couple more people come. I have a document for you today. If you want to use it for reference or if you like to write on it, I don't know. Or if you're just writing on paper, it's still good probably to look at. So I'll put that in the chat for you. And the very first thing on here, it's labeled number 1, but the start of it is going to be our warm-up. So, and you should recognize the idea from what we did yesterday. All right, so for those of you who are just getting here, I'm putting a document in the chat for your review. I'm going to share my screen with you and I'll put up the warm up and then we'll talk Thunderbird Thursday and that kind of stuff in just a minute. So this should be the first one on that worksheet. It doesn't say warm up, it says number 1. But it's the Life of Sunshine DVD players is normally distributed with a mean of 4.1 years and a standard deviation of 1.3 years. So I have a picture for you where you can see the normal distribution and put a title on this graph and make sure you title the horizontal axis and then label your unit and write out all the data values along the horizontal axis. So just like we did yesterday, fill all those things out. And then we'll do the next part in just a minute, but that'll be your warm up. When you're done with all those labels, type to me in the chat what you're gonna have for lunch, because I'm hungry already. All right, are you guys done yet? Nobody typed to me in the chat. All right, so let's take a look at what you put. First of all, anyone in the class, I don't want to have to bring up the wheel. I can, but anyone in the class, tell me anything you wrote on this and where you wrote it. Okay, I'm ready.
I wrote lifespan below the. I can't remember the name of the graph.
So you wrote it right down here at the bottom?
Yeah, but I labeled each of the distributions.
Nice. Excellent. What did anyone else label? Lee got us started.
For the points, for like the points 0.2 and 80 and 8, I labeled it the 99.7%.
Oh, okay. So you labeled percentages on this graph?
Yeah, like for the different ones, like 68, 95, and 99.7.
Okay, so did you label it up at the top, like here?
Kind of, sort of, yeah. Yeah, I did.
Okay. So 68%, and then 95%. I'll maybe write that right here. Probably be nice if I did it in a different color. All right. Good job, Josh. What else did you label? Anyone? Annie, what'd you label?
So I did, I don't know if I was supposed to do this right, but I just did so like in the middle I did the mean, which is 4.1 years. And then
Very nice.
And then I added, from 4.1, I added the 1.3 and then started going up for the rest of it. And then I would subtract on the other side, going down.
Excellent. So verify these numbers for me. Annie, did you get 5.4, 6.7, and 8 to the right of the mean?
Yes.
Okay. Excellent. And to the left of the mean, Zevi, what'd you get to the left of the mean?
I got 2.8, 1.5, and 0.2.
Everybody agree? Excellent. There's one thing we're missing. What's the one thing we're missing? Yeah, a title for the graph. Very nice. So we need a title. Did anyone title their graph? Yeah, good. By the way, if you don't title, you're going to lose points on the test. So make sure you put a title. Make sure you make a note to yourself. So what would you put the title to be on this graph? Judith, how would you title this graph?
Maybe Sunshine DVD players and years or something like that. I don't really know.
Yeah, Sunshine DVD players, maybe lifespan or something. Good, excellent. So don't forget that, okay? All right, so, and here we go. That's what it looks like. This is what I did before, but your title could be different. Now, notice Josh put some percentages on there that we didn't have on, I don't have on mine, but that's awesome because Josh remembered all those percentages from yesterday, which we're going to need today too. So any questions on what we did so far? That should be flashback, right, to yesterday. Okay, excellent. Now, let's talk Z-scores. You had a mini lesson last night, and you should have talked about Z-scores, but you may or may not fully understand them yet. So the empirical rule, those percentages only apply when you're right on 1, 2, or 3 standard deviations above or below the mean. So sometimes we have parts in between, right, that we want to figure out. So a standard score, which is the Z-score, is the number of standard deviations a data value is from the mean distribution, is from the mean of the distribution. So we can plot Z-scores on a special normal distribution called the standard normal distribution. The key to this is right here in this last sentence. The standard normal distribution is a normal distribution that always has a mean of 0 and a standard deviation of 1. So what that is instead of having all these random numbers at the bottom of our normal distribution, we always have the same numbers down there because we're going to put our Z-scores on there. And that enables us to compare different things like ACT scores and SAT scores, right? Stuff like that that might have a different scale. So if we put it on the standard normal and we look at Z-scores, then we can easier compare those different values. So if a Z-score is 0, that means it's right in the middle, right? Because it said the mean is 0. So a Z-score of 0 is right in the middle. If the Z is positive, it'll be above the mean. If it's negative, it'll be below the mean. Okay, seems logical, like a number line. Here is the formula for how you find a Z-score. You take the data value, subtract the mean from it, and then divide by the standard deviation. Okay, if you're wondering where this formula is going to be, I have this formula for you on the test. So if it says calculate a Z-score, you'll see the Z-score formula on there. And if it asks you to use a Z-table will be right there for you, okay? So you won't have to look anywhere for it. The Z-table will be right there. In the meantime, if you want a Z-table and this formula, I will put it in the chat right now so you have it. So you could save that to your drive, bookmark it, you know, make sure you know where it is. So this is a Z-table. And we're not ready for our Z-table yet, but I just want you to get ready for it. There it is, if you want the Z-table. So let's make sense of this. Let's go back to our lifetime of Sunshine DVD players. Notice that I wrote the Z-scores here at the bottom. So this line is 3, 2, 1, 0, -1, -2, -3. So if I see a Z-score of -2, that means that my DVD player lasted less than the mean. Okay, it lasted less time than the mean because it's negative. If I had a positive Z-score, it would say it lasted longer than the mean. Okay, let's just make sure we understand what this formula is doing. So if I have this formula, if I have this formula, Z equals X minus the mean divided by the standard deviation. If I put my X value of 4.1 in there, remember my mean was 4.1 and my standard deviation was 1.3. So I'm going to get 0 divided by 1.3, which is going to be 0, which makes sense. Okay. try it for a different value. Let's put in like 1.5. So if you put in 1.5 minus 4.1 and you divide it by 1.3, let's make sure we understand what z-score we will get. I'm going to do it on my scientific calculator, but everybody try it with their calculators so they make sure they're not making a mistake. Okay, so we want to do 1.5 minus 4.1 and divide that by 1.3. You should get a score of -2. If you don't, you're putting it in your calculator incorrectly. So that's what we want to make sure. And that's what I want to show you. So you're doing 1.5 minus 4.1 divided by 1.3. How many of you got an answer of 2? Sorry, -2. Should be -2, right? Yay. Okay. So if you didn't get an answer of -2, here's my guess of what you're doing. 1.5 minus 4.1. Oh, yeah, that's what it was. Divided by 1.3. Do you see what my calculator is doing? Yeah, it's only dividing the 4.1 by the 1.3. So to fix that, you have to add parentheses there. So 1.5 minus 4.1, end your parentheses, then divide it by 1.3. And then I get the correct answer of -2. Okay, so you might be having parentheses issues. Matt, question?
Yeah, I was just you had the z numbers at the bottom, like 0, -1, -2, and then +1. Would those numbers like always be the same for each? It's always 0, 1, 2, 3. Okay. Okay.
Yes, yes, that's why they're called standard scores. And
Okay.
so they'll always be, so the 1, if you know the z is 1, that means it's 1 standard deviation above the mean. If you know your z-score is -3, you know it's 3 standard deviations below the mean.
Okay. Makes sense. Just make sure.
Excellent. Great. Okay. So now that we have all these numbers here, and you could put the z-scores right underneath them on your paper, right? See, I just added those z-scores. Let's talk about answering a question to make sense of what this is saying. If the z-score is -2, how long would a DVD player from Sunshine DVD last? If the z-score is -2, get that answer ready in the chat. Get that answer ready in the chat, and we'll do a 3, 2, 1 chat in just a sec. All right. Are you ready? 3, 2, 1, go. All right, so be careful of your units, right? What are our units on this problem? They're years, right? It's how long this is going to last. So this is going to last, a z-score of -2 is right here with an x value of 1.5, which means this Sunshine DVD player lasted 1.5 years. Some of you just put 1.5. We did have some dollars and cents in there, which I appreciated. So now that'll make us pay attention to our units, right? Okay, good. So see if you can answer the next 4 questions. Okay, jot them down, then we'll randomly volunteer. So make sure you answer this. This is where Josh's label is going to help us, right? How long do 68% of the DVD players last? How long do 95% of the DVD players last? How long do 99.7% of the DVD players last? And then the last one is, what would the Z-score be for a DVD player that lasts 6 years? And we might have to think about that one, okay? But I think you can do it. So I'll give you a couple minutes on that. When you're done, you can type to me in the chat just that you're done, or if you figured out what you're having for lunch, or if you want to tell me what to have for lunch, I'm all about that too. Go for it. So try those 4 questions on this slide. All right, some of you are still working, I think. Are some of you done? All right. I'll give you another minute, and it's okay if you're not done after that minute. We'll go over them. All right. So some of you might have been a little concerned about how you answer these, okay? So I'll do the first one just so you can make sure. 68% we know is within one standard deviation, either below the mean or above the mean. So it would be from here to here. So if we look at these numbers, it's going to tell us that the DVD players are going to last between 2.8 years and 5.4 years. Makes sense? So if you bought a Sunshine DVD player, you would expect it to last at least over 2.5 years, but it might last as long as almost 5.5 years for most people, 68% of people, right? Okay. So for 95% of the DVD players, how long did they last?
1.5 and between 6.7.
Yeah. So between 1.5 years and 6.7 years. And so if you're me and you buy a DVD player, I don't have very good luck sometimes. So mine might only last 1.5 years, whereas somebody else who buys one, that might last almost 7 years, right? So it's a pretty big span. And then if you look at the 99.7, it's even bigger, isn't it? Lily, between what, how long do 99.7% of their DVD players last?
0.2 to 8 years.
Yeah. Which, hello, 0.2 years? That's not very long, is it? That's not very long, is it? And that would be the one I bought, right? And then other people's it lasts 8 years, which I would think is pretty long for a DVD player. I don't know. What's interesting about this is this helps with things that we'll learn about in the future, like expected value and probability. So what's the likelihood that a DVD player is going to not work? So you know how you can buy warranties when you buy electronics and they charge you a certain amount for the warranty? Well, they calculate what percent of their DVD players fail, and they determine how much they need to charge for their warranty so they don't lose money. It's pretty smart. Those warranties are usually not worth it, right? They're for the company's benefit, not your benefit, okay? But if you're unlucky and you buy a DVD player and it dies in 2 months or 3 months, it would be under warranty and you would be able to get it fixed. What did you get for your Z-score down here? Did anyone figure out how to calculate that? Remember, our Z-score formula is X minus the mean divided by the standard deviation. So what number would we plug in for X?
6.
Yep, so 6 minus, and the mean was 4.1, and the standard deviation was 1.3. So what did you guys get for that one?
1.46.
Yeah, 1.46 or so. So what that means with a Z-score of 1.46, remember this is a Z-score of 1, this is a Z-score of 2. So it'd be almost right in the middle, right? So if you had a Z-score of 1.46, notice it says that would last 6 years. And if you look at our X values there, this one's 5.4 and this one's 6.7. So 6 is right there in between those two. Nice. Now, what do we do with those Z-scores? We go to a Z table like this. Now, if you Googled Z table, you'll get a million different Z tables. They'll be to different preciseness. This one is not super precise, but it's perfect for what we need it to do. And so notice most of the time it only goes to 1 decimal place. Sometimes it goes to 2 decimal places. So if you look at this table and we have 1.46, but I don't see 1.46 on this Z table. So let's make sense of the Z table first. It says, okay, these are areas under the standard normal curve. So it's telling us about what's underneath the curve, which would make sense. Let's flash back and look at if we had a Z-score of 0. A Z-score of 0. Notice that my area is, so if my Z is 0, my area is 0.5000. What percent is that?
50.
Yep, 50%. Remember, you multiply it by 100, which would move the decimal point 2 to the right. So it would be 50%. Now that should make sense because what that's saying is, okay, if you have a normal curve and you have a z-score of 0, then the area to the left is 50% or 0.5. And that makes sense? Now, the area to the right is also 0.5 because it's right in the middle. But we could find the area to the right by subtracting 1 or 100% minus the area to the left. Okay? So if we were just going to locate that 1.46 on this table, we can't. I can see 1.4 and I can see 1.5, but there's no 1.46. Which value do I use? Should I use the 1.4 or the 1.5? Which is closer to my 1.46?
I would say 1.4
Why?
because it's 46. So I feel like if it would have been over the 5, it would go to 1.5.
So
That's just me guessing.
what do you guys think? Zach, what do you think? Should we use 1.4 or 1.5?
I would have done 1.5 just because it's closer to it.
Okay. So 1.46 is closer to 1.5 than 1.4, right? Because the number to the right of the 4 is a 6, so it's 5 or higher. So you use rounding rules. We're going to round up to 1.5. Okay, so we're going to use this one. And it says that area is 0.9332. What percent is that?
$93.
Yeah, it's like 93.32%. So if we look back at our picture here, if we have a z-score of 1.5, which was approximately our z-score right here, then it's saying that this area to the left, right here, this area is 0.9332 or 93.32%. If I want to find the area to the right, I want to find this area, I could do 1 minus 0.9332 or 100% minus 93.32%. What would I get if I did that?
$6.68.
Very nice. So this area over here is 6.68% or 0.0668. So notice that these two numbers sum to one whole, or these two numbers sum to 100%. That's what it's telling you. So on the table, any of the numbers you see there are the area to the left. If you want to find the area to the right, you'll have to do 1 minus that. So let's make sense of what this means. So a DVD player that lasts 6 years is going to last longer than 93.32% of the other Sunshine DVD players. So only 6.68% last longer than 6 years. Does that make sense? All right, so that's what we're trying to do here with z-scores. So here's a example that's already worked out for you. The context is a little different. Now we have a standardized test. if we find the z-score, it says what percentage of students scored less than 650 on the test? Well, first we know it's a normal distribution. It has a mean of 510 and a standard deviation of 95. So when it asks you what percentage of students scored less or more or weighed more or less or whatever it's asking you, the first thing you're going to do is find a z-score. Okay, that's the very first thing you do. So we found our z-score, and notice they found the z-score is really close to our last z-score. And so we would have a very similar result on this. So anyone ever remember taking a standardized test and getting the results back and they told you like you scored in this percentile? Do you remember that? Yeah, that's what this is. So if they have this, they would say you scored in the 93rd percentile. And when they say that, that means you scored higher than 93% of the people who took the same test. Or you scored lower than 7% of the people who took the test, right? So you did pretty good is what I'm saying. So that's what z-scores are very helpful for. Okay, we already talked about this a little bit, so you're good. Let's see if you can just envision what we're talking about here. If I give you the area to the left, how do you find the area to the right? What do you do? What do you do? If I give you the area to the left, how do you find the area to the right?
I'm thinking maybe I don't know. Honestly, maybe subtracting or something. I don't know.
You're absolutely correct, Judith. What are we going to subtract from?
You're gonna subtract I'm not sure, but I know. Yeah, I'm stuck.
So if we look right here at the top of our z table, if we're given the area to the left, how do we find the area to the right?
Oh, 1 minus area to the left.
Very nice. So we're going to do 1 minus the area to the left. So we're just going to go 1 minus 0.123.
Yeah.
Perfect. So if you do that, you would get 0.877. Now, if I was looking at that, I only have about 12% with the area to the left. So that would be probably right around here or so. So this would be our 12%, the area to the left, which would mean our area to the right is much bigger, like 87%. So if you got a result that said you're in the 12th percentile, that's bad, right? If it's a test score, because you did well below the mean. Okay, now this second one's a little bit tricky because it says, okay, I'm going to give you the area to the right. How would you find the area to the left? Any ideas? Brady, any ideas on that? If they give us the area to the right, how would we find the area to the left?
Sorry, my mouth shut down for a second. I was struggling there.
Anyone help Brady out?
Find the area on the left. Well, you can just subtract the area on the right from 100, and then you have the area on the left.
Perfect, absolutely. So we actually do the exact same thing. We just do 1 minus 0.543. Okay, so it doesn't matter which side we get. If it totals one whole or 100%, we just subtract the other part from 1 or 100%. Yeah? Good job, Brady. All right, so our answer on that one would be 0.457. If you were looking at that, if it says the area to the right is 0.543, that's bigger than 50%. So our line must be about here, because remember the middle is 50%, and it said the area to the right was 54%. And the area to the left would only be 45% or almost 46%. You okay? All right. Now, on your paper, you can see you have pictures by each one of these, right, on the worksheet that I gave you. So let's start here where it says a variable is normally distributed with a mean of 84.6 and a standard deviation of 19.1. It wants you to draw everything and label it. So can you do that first? Label it with X values and Z scores, okay? And then we'll try to answer the questions in just a second and shade. But label all those first. All right, let's just start by how we labeled, okay? So I'm hoping that you put 84.6 here, yeah, in the middle. Excellent. And those are our X values. And then our Z values are the easy one. The Z values are just 0, 1, 2, 3, -1, -2, -3, right? So on your problem right here, did you get 103.7, 122.8, 141.9, and then to the left, did you get 65.5, 46.4, and 27.3? Is that what you guys got? Excellent. Now let's look at this first question. It says find the area to the left of 60.5. So what do you think the first thing we have to do is?
Find its Z score.
Exactly. Find a z-score. So we're going to do 60.5 minus 84.6 and divide that by 19.1. So do that calculation. And get it ready in the chat, your answer to 2 decimal places. Get it ready in the chat, your answer to 2 decimal places. All right, 3, 2, 1, go. There we go, look at that. Excellent. Very nice. Any questions on how we got negative 1.26? If you didn't. Now, before we go any further, let's think about what that means. What does a negative z-score mean?
It's below like the average mean.
Very nice. It's below the mean, and it's below the mean by over 1 standard deviation, right? Okay, so if we were going to draw that, like in this picture, do you see how it says shade the solution region? So if we were going to label this negative 1.26, it would be about right here, right? Because there's negative 1 and there's negative 2. So it would be between negative 1 and negative 2. And then this one says the area to the left. So I'm going to shade all of this. This is the solution we're talking about. Now we have to go back to our Z table and find the area, okay? So you could have used the Z table that I put in the chat already. I'll just scroll up to the other page. So we're going to look up negative 1.26. So let's look that up. So here's our negatives. Be careful, make sure you look up the right thing. So here's negative 1.2. Oops, sorry, I went a little too far. Here's negative 1.2. Here's negative 1.3. Which one do I use? Lily, which one do I use?
Negative 1.3.
Very nice. We use negative 1.3 because negative 1.26 would round to negative 1.3. So I'm going to use that number 0.0968. So 0.0968. That is my area under the curve. If you wanted to write it as a percentage, it would be 9.68%. So notice that's all that's right here. So that's my answer to part A. Notice that part B is connected to it, right? Part B says, what about the area to the right? Well, I could find my z-score again, right? I could look at the table. I could write it down. Or what else could I do to make it shorter for me?
Just
Vanessa, any ideas? Oh, Matt, go ahead.
Just subtract that that left z-score on the other side of the 60.5.
Exactly. I could just subtract from 1. So I could go through the whole z-score. I'll get the right answer. But to save me some time, I might just do this. And I would get, what did you get, 90.32.0, sorry. 0.9032. which looks about right, right? Like I have a lot more in pink than I do in yellow. Okay, excellent. Did you do C and D yet? Okay, do C and D, and a challenge, I'll give somebody extra credit if they get the answer to part E correct. Okay, so challenge, do C, D, and E. C, D, and E. When you have an answer to E, send it to me directly in the chat. Don't send it to everyone, okay? Go for it. All right, so let's start. Zach was super duper close. He's almost there. So let's talk about this. Part C, a couple people sent me their answers to C. For C, did you get 0.9893? Very nice. So let's look, 0.9893. So it says the area to the left of 128. So the first thing you do is find your z-score. So you go 128 minus 84.6, and then you divide it by 19.1, right? Any questions on what I did there? So for your z-score, did you get 2.27-ish? Yes, okay, so when you got that 2.27, you go to the z table. Let's go back up to our z table. 2.27 and so you find that on your z table. Which it must be closer to 2.3. So there's your 98.93. Do you see that? Questions on that? Remember, we're finding the area under the curve. So when I see that 0.9893, what that means is I'm going to take off some of this highlighting so we can get there. Remember, our z-score was 2.27, so it was about right there. And so doesn't it look like a whole bunch of area under the curve? That's why that number is so close to 1 or 100%. And it was the area to the left, so that's our answer. All right, on D, what did you get for D? D was a little tricky because did you notice it said area to the right? Did you catch that? Okay, so first you found your z-score. Was your z-score 1.82? And so the area to the left was the 0.9641. But since we wanted the area to the right, we needed to subtract. How many of you remembered to subtract and got your answer of 0.0359? Who got it right? Lee got it right. Uh-oh. Did anyone put this as their answer? This 9641? Did anyone think that was their answer? Yeah, a few of you. So it tricked you, right? That one word got you because it said area to the right instead of area to the left. Don't get frustrated on your homework, right? Make sure you're careful and you look at that. Any questions on D? Better now? Okay, good. Now E, some of you are putting in the chat, I'm not sure, I don't really know what to do. So I'm going to erase this so you can see what we're really trying to do. So we want to find the area between things now, between 80 and 90. So the first thing you're going to do is find your z-scores for each one of these. So you're going to do 80 minus 84, what was it? 84.6 divided by 19.1. The other one you're going to do 90 minus 84.6 divided by 19.1. And V sent me in the chat that one of the z-scores would be negative 0.24 and the other z-score would be 0.28, right? Okay, so V, you were on your way. You were almost there. So now what you do with those, if you wanted to think about where those would be on our picture, here's negative 0.24, right? Real close to my mean. Let me see if I can make that a finer pen line. So there's negative 0.24, and then and then positive 0.28. And what we're really interested is looking at the area between these. So it's not very much. If we go to our table, we'll be able to find these numbers. And Zach put them in the chat for me. Zach has the numbers. Let me find where Zach's is. 0.4207. Let me write that. 0.4207 and 0.6179. Do you see where we got those on the table? If you go to your Z table, you could find those two values. You want me to show you? Okay, so if we go to the Z table, let's erase all of these guys. So this time we want negative 0.24. So negative 0.24. So we have these two are our choices, right? Those two are our choices. So this one might not follow the rounding rules as well as the other ones, right? But if you think about it, what it's asking you, if our two choices are negative 0.24, or if our z-score is negative 2.4, and our two choices are 0.25, negative 0.25, or negative 0.20, which one would we look at on our table? And so this might be a little troubling for some of you, okay, to decide where you're going to look. So I would look at this one, 4013, because even though it rounds down, I want you to think about this. Which one is it closer to practicality wise, not rounding wise? Which one is it closer to? It's actually closer to this one. Do you see that? Even though it wouldn't round that way, it's closer to it because it's only 1/100th away from that one, but it's 4/100th away from that one. So I'm going to look at this 0.4013 instead of the 0.4207. Zach, does that make sense? Okay, good. And then the other number we had was 0.28, which again, we have 0.25 or 0.30. Well, it's closer to 0.30. So I'm going to use that 0.6179. Okay, so now we're going to change this. Instead of 4207, we're going to use the other one, which was what, 4013? Now, I think real hard here because this is going to help you when you're doing your homework. So this number right here, 0.4013, was the area to the left of this negative z-score. The other number I had was this 0.6179, which would be the area to the left of that value. So do you see how those two overlap? See how those two overlap? Well, I want just this part, right? I want just this part. What would I do with these two values to get the answer?
You would subtract the difference.
Yes, very nicely. So we're going to go 0.6179 minus 0.4013. And we get 0.2166. Yeah? Is that what you guys got? Now that we did it together? Excellent. So when it says find the area between two values, you have to find the area to the left of both values or to the right of both values, depending on what it's asking you, and then subtract them. And that will give you that answer. There it is. Yep.
Sorry, I was wondering. So that last one, when we went to the chart, you had us or you so we were looking for the 2.7 z-score, right?
We were looking for 0.28. This one right here.
It was negative 2 point
Oh,
something.
this negative 0.24.
Right. Could you go up to the chart real quick?
Yeah.
So basically what you're looking for is just the two numbers that are closest to it?
Well, you would love it if it said negative 0.24 on your Z table, but it doesn't.
Yeah.
So we're looking for what's closest to negative 0.24. Well, here's my choices: negative 0.25 or negative 0.20.
Okay. So it's always going to be like using those two numbers.
Yeah, you're going to pick whichever's closest.
What if there's like a negative, like just a negative 0.20? Would you just use the 0.20 one?
Yep, you would just use this one. And we only use the 0.25.
Okay.
I was just showing how we kind of decide which one to use.
Oh, okay. All right. That was okay. I was confused.
And remember how I said different Z tables will be different preciseness. So some of them will give you more values here, but since this is what we have to use, we'll just go to the closest value.
Okay. Yeah, makes sense.
Good question, Matt. Okay. So that's it. I know that S6 is still probably a little muddy for you, right? It's not clear as day yet. That's why we're spending Monday on it as well. Okay. So that's why we're doing this again on Monday, to make sure we understand. So if you look at your homework, you have, it said S5 was due last night, but I changed it. It's due tonight. So I changed that for you. You'll notice that due date changed. You also have an assignment called Info on Taking a Proctored Test that's due on Sunday night. You have a practice lockdown browser due Sunday night. Don't start that really late, because if you have to download things or you're having internet connection issues or whatever, you'll run out of time. So make sure you do that well in advance. You're also going to have more S6, but notice it's not due until Monday night, because we're going to go over it in class again. So you can start it, but just know it's not due yet. Okay. And then your statistics review is due on Tuesday. So make sure you start on that as well. So it looks like a lot of assignments. It won't be unless you wait till the last minute. Okay. If you wait too long, then it will be overwhelming. Now, a couple of you, I'm suspecting, I know, missed some assignments through the statistics module, right? You forgot to do a mini lesson, or you didn't finish an assignment, something like that. Is that true? Okay, I'm going to open back up all those assignments, okay? Not your reading quizzes, but I will open back up all your statistics module mini lessons and practices, and I'll keep them open till Tuesday night, okay? So if you've already done them and you've gotten 100%, don't redo them. But if you missed one, or if you wanted to fix your grade on some, it'll be open for you, okay? Yeah, see, V gets it. Okay, good. So does Lee. So we got it now. I'm trying to be nice to you. I want all that homework done so you do well on the test, right? Okay, but don't get behind on the new homework. Okay, I'm going to put your exit ticket in the chat. And then you guys have a terrific weekend. Don't forget to study, right? And stay on here, ask me a question if you need anything.
Bye, everyone.
Have a good
Bye.
weekend, guys.
Have a great weekend.
Thank you. Bye.
Bye.
Johnny.
Thank you, Miss Klassen.
Yeah, bye, V.
Bye. Have a good weekend.
You too.
I had a question for the table. That will be, we obviously will be, sorry, my internet's bad. For the table, we will be using, I mean, that table will be on the test, right?
Yep, it'll be in the
Module
question.
3 statistics, Z-score table.
Yep, it'll be in the question on the test.
Okay.
Yep. Lily, what
Megan, what
did
are your
you
office
do?
hours?
Do you know what you did?
I had gotten it right, but I decided to look through the Z-score.
Yeah, yeah, and you're not alone. So don't give me the area when it asks for the Z-score. Just give me the Z-score.
Oh, okay, okay. Thank
Okay.
you so much.
Yeah,
I
no
have a-
problem. Good job.
Thank you.
Bye.
I was just asking your office hours today. I haven't looked at your, I was wondering what your office hours were today.
I had office hours this morning. I don't have any more today. Because I have
Okay,
meetings
and then you
all
don't have any
afternoon.
Friday.
Nope, because I have
Okay.
meetings all tomorrow too. So, but
Okay,
that's why
then.
I had
Awesome.
them
Thanks.
last night. So, but the tutoring center is there as well.
Okay, thank you.
Okay.